Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can help me promote my channel to keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Here is example 31 on finding the resultant of concurrent non-coplanar forces. An upward 2000 Newton force is applied at end A of the vertical pole, where two cables are also fastened. The tensile forces in these cables are FAC 4000 newtons and FAD 5000 newtons. So determine the resultant of the three forces applied to end A. So let's express each force into vector expression, then we also express the resultant in vector form. So first for FAC, magnitude is 4000 newtons. It is directed down, so negative along Z, to the left, negative along Y, and forward, positive along X. So since this is a right triangle and the force is directed in that direction, we first compute this component. This component is projection on the XY plane is 4000 hypotenuse times cosine of 30, because this is 30, or 4000 sine of 60. This should be 60 degrees because this is a right triangle. Then times, after computing this projection on BC, we multiply cosine 50 degrees, then that's I, then minus this one, sine of 50 degrees J, then minus also because it's going down, 4000 sine of 30 degrees K. So it is equal to FAC, magnitude 4000 cosine of 30 degrees times quantity cosine of 50 degrees I minus sine of 50 degrees J. Then we have a separate component for FAC along Z, which is negative 4000 cosine of 60 degrees J, or negative 4000 sine of 30 degrees K, rather, not J. 4000 sine of 30 degrees K. So simplifying, FAC in vector form, 2227I minus 2654J minus 2000K, wherein this is negative 2000 K. Then for FAD, if this is 45 degrees, this is also 45 degrees. It has only Y and Z component. The Y component is positive in that direction, and the Z component is downward, therefore it is negative. And remember, this is 45 degrees. So FAD in vector form is equal to 5000 times quantity sine of 45 degrees I, because this is 45, then minus 5000 cosine of 45 degrees K, this component. Simplifying, FAD is equal to 3536J minus 3536K. So again, FAD is the Z component is positive, 5000 sine of 45. This is also 45J. Then the Z component is downward, so negative 5000 cosine of 45 degrees K. So that's the vector expression for FAD. Finally, for FAZ, it is just positive 2000 K as shown. So adding these components, the resultant will have 2227 I, then negative 2654 plus 3536 J, then negative 2000 minus 3536 plus 2000 K. So the resultant is the sum of these vectors of these forces. So it is 2227I plus 882J minus 3536K. So that's the resultant in vector form. Now for your part, here is your problem. So this is the same figure. Two cables are attached to the vertical pole AB to steady it. An upward force of 2000 newtons is applied to the pole, with the effect that the resultant of the three forces acting at point A on the pole is parallel to the x-axis. So the resultant is parallel to this axis here. So determine the tension in the two cables and the magnitude of the resultant. So tension, tensile force in its cable, and the magnitude of the resultant, and show that this would be the answers. FAC 1790 newtons, FAD 1630 newtons, and the resultant, the magnitude of the resultant is 956.9 newtons. So that's it for your part.